Hi, I'm Idjiram Abdulbasir on Civil Engineering 2A. So provided we can do this integrals, a particular solution to the differential equation is y sub b of t is equals to y sub 1 times u sub 1 plus y sub 2 times u sub 2 is equals to negative y sub 1 integration of y sub 2 times g of t all over Wronskian times the quantity of y sub 1 comma y sub 2 multiplied by the derivation of t plus y sub 2 integration of y sub 1 times g of t all over Wronskian multiplied by the quantity of y sub 1 comma y sub 2 multiplied by the derivation of t. So let's summarize up what we've determined here. Consider the differential equation y double prime plus q of t times y prime plus r of t times y is equals to g of t. Assume that y sub 1 of t and y sub 2 of t are fundamental set of solutions for y double prime plus q of t multiplied by y prime plus r of t multiplied by y is equal to 0. Then a particular solution to the non-homogeneous differential equation is y sub b of t is equals to negative y sub 1 multiplied by the integration of y sub 2 multiplied by g of t all over Wronskian multiplied by the quantity of y plus y comma y sub 2 multiplied by the derivatives of t plus y sub 2 integration of y sub 1 times g of t all over Wronskian multiplied by the quantity of y sub 1 comma y sub 2 multiplied by the derivatives of t. Depending on the person and the problem, some will find the formula easier to memorize and use, while others will find the process used to get the formula easier. The example in this section will be done using the formula. Before proceeding with a couple of examples, let's first address the issues involving the constant of integration that will arise out of the integrals. Putting in the constant of integration will give the following: y sub b of t is equals to negative y sub 1 multiplied by the quantity of integration of y sub 2 multiplied by g of t all over Wronskian multiplied by the quantity of y sub 1 comma y sub 2 multiplied by derivatives of t plus the constant c plus y sub 2 times the integration of y sub 1 times g of t all over Wronskian multiplied by the quantity of y sub 1 comma y sub 2 multiplied by the derivatives of t plus k is equals to negative y sub 1 times the integration of y sub 2 times g of t all over Wronskian multiplied by y sub 1 comma y sub 2 multiplied by derivatives of time plus y sub 2 integration of y sub 1 g of t all over Wronskian times the quantity of y sub 1 comma y sub 2 multiplied by the derivatives of t plus the quantity of negative cy sub 1 plus ky sub 2. The final quantity in the parentheses is nothing more than the complementary solution, which c sub 1 is equals to negative c and c sub 2 is equals to k. And now that if we plug into the differential equation, it will simply out to 0 since it is the solution to the homogeneous differential equation In other words, these terms and nothing the particular solution, and so we will go ahead and assume that C is equal to 0 and K equals 0 in the examples. One final note before we proceed with examples: do not worry about which of your two solutions is complementary. Solution y sub 1 of t and which one is y sub 2 of t, it doesn't matter. You will get the same answer no matter which one you choose to be y sub 1 of t and which you choose to be y sub 2 of t. Find a general solution to the following differential equation. 2 to the power prime plus 18y is equal to 6 tan times the quantity of 3 multiplied by t. First, since the formula of variation of parameters requires a coefficient of a 1 front on the second derivatives, let's take care of that before we forget. The differential equation that we always actually be solving is y double prime plus 9y is equals to 3 tan times the quantity of 3 multiplied by 2, because 2y double prime plus 18y is equal to 6 tan times the quantity of 3 times t. We divide both sides by 2. So we got y double prime plus 9y is equal to 3 tan times the quantity of 3 times t. We'll leave to you to verify that the complementary solution for this differential equation is y sub c of t is equals to c1 cosine times the quantity of 3 times t plus c2 sin times the quantity of 3 times t. So we have y sub 1 of t is equals to cosine times the quantity of 3 times t. Y sub 2 of t is equal to sin times the quantity of 3t. The Roscans of these two functions is Roscans is equals to absolute value of cosine times the quantity of 3 times t, negative 3 sin times the quantity of 3t, sin times the quantity of 3 times t, 3 cosine times the 3 times t is equals to 3 cosine squared times the quantity of 3 times t plus 3 sin squared times the quantity of 3 times t is equals to 3. The particular solution is then y sub p of t is equals to negative cosine times the quantity of 3t, integration of 3 sin times the quantity of 3t times tan the quantity of 3t all over 3 multiplied by the derivatives of t plus sin multiplied by the quantity of 3 times t, integration of 3 cosine 3t times the tan of 3 times t all over 3 times derivatives of t is equals to negative cosine times the 3t, integration of sin squared times 3 times t all over cosine times the 3n times t times the derivatives of t plus sin times 3 sub 3t, integration of sin 3 times t times the derivatives of t is equals to negative cosine times 3t, integration of 1 minus cosine squared times the quantity of 3 times t all over cosine times the quantity of 3 times t times the derivatives of t plus sin 3 times t times the integration of sin 3 sub 3 times t times the derivatives of t is equals to negative cosine times the quantity of 3 times t times the integration of second times the parent 3 times t is minus cosine 3t derivatives of t plus sin 3t integration of sin 3t derivatives of t is equal to negative cosine times the quantity of 3 times t all over 3 times the logarithmic section all over second times the quantity of 3 times t plus tangent 3 times t is minus sin times the absolute value of 3 plus sin 3t all over 3 times the quantity of negative cosine times 3t is equal to cosine 3t all over 3 times the ln all over second times the quantity of 3t plus tan times 3t. The general solution is y of t is equals to c sub 1 cosine times the quantity of 3 times t plus c sub 2 times sin times 3 times t minus cosine times the quantity of 3t all over 3 ln all over second 3t plus tan multiplied by the quantity of 3 times t.